Thank you for the opportunity to present urban strategy and the digital twins we build for livable and resilient cities. My name is Jeroen Borst. I work at TNO Research Institute, independent from the Netherlands. And my role is to develop and to tell the story about urban strategy, the instrument we use for this. And why is it important that a research institute builds digital twins of cities? Well, that is because decision making around cities is very complex due to, well, urbanization and densification. More and more people live in cities nowadays, um, combining more and more functions on the same square meter. And a big challenge is where do we put our new houses? In the Netherlands, in Asia, in the US, we see a housing challenge with the big question, where can we build provided the limited amount of space and all the regulations? And how do we keep our cities livable for everybody, given that we have to combine all these functions on that same square meter? And how do we avoid car dependency? How do we design our cities in such a way that we retain accessibility for everybody? For instance, by using the bike. Well, me coming from the Netherlands, it's very useful to think of cycling as one of the important modes of transportation, especially in the inner cities. It's a very efficient way to get around. But also a big question is how do we get people to use public transport? How do we make the model shift towards transit, in other words? And how do we keep it affordable for the travelers as well as the passengers, as well as the municipality or the government? And how do we provide accessibility for all, also for the people not living in the city center, but living in the outskirts, in the suburbs? And what is the impact of electrification? What happens if all the functions become electric with the eye on sustainability? But what has to happen in the city? What does it mean for city planning? And more in general, how do we get to net zero? How do we make sure that we do not longer emit CO2 in order to prevent climate change? But while climate change is going to happen, how do we mitigate climate risks? How do we avoid urban heat or urban flooding? And how resilient is our network in order to cope with these changes? And if we have to adjust our city, if we have to prepare for the future, basically every street in the city has to be opened up. It's a big transformation of the city. How do we keep the city livable and accessible during these many transitions? And the basic question is, how do we secure sustainable well-being for everybody living in and around the city? And in order to meet this challenge, how can digital twins help us with these challenges? Does digitalization help us? And this is the basic knowledge question of my program, and this is the reason we have been building digital twins for the last decades, actually. So to summarize the problem statement, we see this increasing complexity of decision making, also because in many cities decision making is organized in silos. Every domain has its own experts in its own department. And because of the state of the art of all the tooling that we have, it's very timely to make decisions. And sometimes the quality of the decision is suboptimal because we do not have a holistic view of what's happening and what the consequences of our choices are. And therefore we built Urban Strategy to create an entire view over the entire city and to be able to do cross-domain impact assessments. To do that interactively, so you immediately see the impact of a decision in this digital twin, so the quality of the decision making is improved. You see what is happening on the multiple domains, and you do not forget one aspect, because everything is taken into account automatically. And when we look in the world, we see many examples of digital twins. In many cases, combining data, many types of data, forms of data, and visualizations. And those visualizations can be very neat, they can look magnificent, but in many cases what is missing is the analytics, and that is especially what we have been focusing on. Linking simulations, very fast simulations, to the data and to the different visualizations we have of the cities, creating the combination of the 3 points of this triangle. And once we do that, we can create interactive digital twins, combining multiple domains and interventions and all the perspectives of the stakeholders in the city in one go. And in order to be able to do that, we have been building simulations and implementing them on graphical processing units, making them tremendously faster than the current state of the art on these domains. So from spatial planning to mobility demand, to the usage of the networks, not only the roads, but also public transport, as well as active transportation, cycling, walking. We can assess the distribution of accessibility for different target groups, and we can assess the environmental impact of all the activities in the city. So we can look at the different components of air pollution due to road and industry, and we can assess the noise, not only the emission but also the decibels, including the impacts. And because more and more of the activities are becoming electrified, we have to build also simulations on what does this mean for well, the operations of public transportation, for instance, if we make that electric. And also what is the interaction with the current power grid, and where does it have to be reinforced if the usage as well as the generation of power is changing and is differently distributed over time and place in the city or region. And then of course we look at climate mitigation, greenhouse gas emissions, but also the resilience of our infrastructure to, for instance, flooding. We look at spatial impacts and to sustainability indicators. Sustainability indicators as well as well-being indicators. And to summarize the value of putting this in one digital twin, you can say in the traditional way we used to look at one single domain, one scenario per day, and very long decision-making times, limited options because the time was so long, and we had the difficulty of integrating the different silos. Now we can combine the different silos and run multiple scenarios in one go, leading to shorter decision making times, a larger range of options, and reducing the cost of the decision-making process. Well, one example of one example that we are proud of is the cooperation that we have with our capital, Amsterdam, where the challenges summarized in the previous slides were actually mentioned by the vice mayor together with his CTO officer and the department responsible for transportation and public space. And together we implemented this way of working, the digital twin, the interactive digital twin. And now Amsterdam is using the digital twin urban strategy for their strategic decision making, as well as use cases that are more tactical, how to plan multiple roadworks, for instance, all with an eye on retaining livability for all. And then this is a view of how such a digital twin looks like. A virtual representation of the city, in this case Amsterdam, in which we can project different layers such as noise or air quality in this environment. We can look at these different aspects and assess them for decision making. And basically these are the two sides of the triangle of the digital twin, the visualization of data and of outputs. But then if we add the third point of the triangle, the interaction, we can actually show how we can grasp any data element in the digital twin and see what happens if we alter one. Well, to provide an example of that, this is the road network of Amsterdam projected on a map layer through a web interface. And now we add a control, as we call it, to one of the data elements. And in this case, it's a part of the ring road in one direction of Amsterdam in the central business district. And once we enable this control, this part of the highway is being shut down, having an effect not only locally on the amount of traffic represented in the blue bands on and around the roads, but it also has an effect on all the traffic detouring throughout the city. Where it's red, you will get more traffic due to this intervention. Where it's green, you have less. And also air quality is affected. Due to this simple measure, closing down one road in the city, basically air quality in the entire city is affected. Some places it will improve and some places it will worsen. And of course, the same will go for all the other effects such as noise. Well, Amsterdam uses this for very strategic planning of new housing or parking tariffs or the tariffs for public transport and also infrastructure planning, but also for tactical planning like the renovation of the quays and bridges in Amsterdam. With a traditional way of working, combining roadworks in the inner city was quite a cumbersome process. And now with urban strategy, Amsterdam plans roadworks in a much more efficient way. Another example on a bit of a different scale is San Diego. In San Diego, we also built the digital twin. We trained the people of different entities in and around San Diego to work with the digital twin, and now they are able to evaluate the first version of this digital twin that is in place now in San Diego, an area where around 3.5 million people live. And same as in Amsterdam, in this digital twin, we combine different data layers, such as the build-up area, basically all the buildings and their functions, the transportation networks, such as all the roads, including their capacities and the speeds and the accessibility, and of course the public transit lines, public transport in the larger area around San Diego. In fact, it's the entire county. And again, here in San Diego, we are able to run scenarios, and the city is able to run scenarios using this digital twin, such as closing down or opening up new parts of the infrastructure, and assess immediately what the impact will be of such a measure. And one of the measures that we have been using as an example is the closing of the Coronado Bridge, bit similar to the example of Amsterdam, where closing down one part of the infrastructure will basically lead to a shift in how the transportation network is being used in a much larger area, but also a shift from car to public transport if we keep that open. In this case, public transport will become more attractive if the bridge is still open for the bus, for instance. And again, also leading to a shift in air quality, in pollution, and same goes for noise. We can also look at well, how urban development, so new housing, but also parking fees and the encouragement of bike usage can all be combined in scenarios in order to get well, to improve accessibility of San Diego, in fact. And what is happening in California, already in San Francisco, is the introduction of robo-taxis. And one of the scenarios that we can run in such a digital twin is what the impact would be of such a new modality. What would happen if robo-taxis, such as a Waymo or a Cruise, would be introduced without any regulation? And what we see is, due to the attractiveness, potential attractiveness of such a new mode, more people will use this type of car, actually well, reducing accessibility because of the congestion that will occur in the city. And one example in Asia of the application of urban strategy is in Singapore, where we used urban strategy to assess the impact of the electrification of the entire bus fleet. Well, a last example is work that we do for the National Road Authority in the Netherlands, where we look at how vulnerable the network, the road network is to climate change, to flooding, to be more precise, and what the impact would be of flooding in a particular area. And then very briefly, I will take you along with the next steps that we foresee in working with the digital twin. Well, you could say up to now, in this triangle, we build a SimCity for professionals, where a scenario, as we showed, can be assessed very quickly. But now the question that we get is, can we also optimize? And well, basically yes, but in order to optimize, we have to find a way to put a goal function, including constraints, into an optimization algorithm. And then to quickly assess which combination of input parameters brings you closest to this goal function. But the formulation of a goal function is quite complex, and therefore we foresee a role for generative AI to translate the question in human language to a goal function that is more abstract. And using such an instrument will lead to an advice for an urban plan that still has to be discussed with humans in the loop. And the first versions will lead to a reformulation of the question, like, where can I build new houses? To train the AI algorithm what we actually mean with such a question, to update or to improve the goal function that we're working on. And working in such a way makes it actually more transparent what we are actually optimizing on. So what we see for the future is that we go from simulation to AI-powered optimization for urban planning. Thank you very much for your attention. And if you want to know more, well, please contact us. Thank you so much.